All right, and welcome back. So today we are going to be talking about how to solve absolute value inequalities. We're going to have some similar characteristics here as to how we solved absolute value equations, but now we're going to be transferring that knowledge on how to solve absolute value inequalities. It's going to be similar, but it's going to be slightly different because we will be having to use our knowledge on how to work with compound inequalities, but we will get to that in just a moment. But without further ado, let's begin. So to solve an absolute value inequality, we first have to use our inverse operations to isolate the absolute value expression. Then we're going to write and solve a compound inequality. So we're taking our knowledge of compound inequalities and we're applying it now to our absolute value inequalities. But we're going to treat it similar to how we would solve absolute value equations, where we have to isolate our absolute value expression. We want to get whatever is within those bars, we want to get that isolated all by itself on one side of now our inequality sign. So without further ado, let's go through an example together, and then we'll talk about why we are doing what we are doing. So let's say we want to solve the absolute value of x minus 2 plus 8 is less than 10. Well, we first want to isolate the absolute value expression. Currently, it's not isolated. We have that plus 8 on the left-hand side of our inequality sign. So we want to subtract 8 from both sides. You sometimes hear it being referred to as to add negative 8. It's the same thing as adding a negative or subtracting. So now we have the inequality, the absolute value of x minus 2 is less than 2. And now we have fully isolated our absolute value expression. We have the absolute value of x minus 2. We don't add 2 to both sides because it's within the absolute value expression all by itself. So now we're going to solve a compound inequality. Think about back when we had our absolute value equations. Well, if it was the absolute value of x minus 2 is equal to 2, well, then it would be x minus 2 equals 2, or x minus 2 equals negative 2. So we have two different scenarios here. But now we're going to take that knowledge and apply it to our inequalities, which is where our compound knowledge comes in. Well, we have a less than symbol. So since we have a less than symbol, we're going to use the compound of and. We're going to use the compound of and. So we're going to break it up from the absolute value, and we're now going to have x minus 2 is less than 2. And we're going to have x minus 2 is greater than negative 2. When we change the sign on the right-hand side, when we slap on that negative value, we have to flip our inequality sign. Because when we solve it, we're going to be having an and result with a number that can fall between two values. So when we solve it, we add 2 to both sides in both instances, and we get x is greater than 0 and x is less than 4. And this should make sense because we can think of a number that is between 0 and 4, a number that's bigger than 0, but a number that's less than 4. 1, 2, 3, 3.5. All of those would satisfy this inequality. So since we have a less than, we want to use an and. So it's kind of sounds similar. Less than sounds like and. So when we have a less than absolute value inequality, we then use the and aspect of our compound inequality. We're then going to graph it as we normally would. We have x is greater than 0, so it's an open circle at 0. X is less than 4, it's an open circle at 4, and we shade in between, showing that we can have numbers that are greater than 0 but less than 4. Awesome, folks. With this in mind, please work on problems 1, 2, 3, and 4 on the note sheet and resume when you are ready to go on. All right, if you listen to my voice, that means you worked on problems 1 through 4 on the note sheet and you're ready to move on. So you can use a similar method to solve absolute value inequalities that involve a greater than symbol. In our previous example, we talked about what happens when we have a less than symbol, but now we're going to talk about how to do it when we have a greater than symbol. But as always, the first step is to isolate the absolute value expression and then work with a compound inequality. So let's say we have the inequality of the absolute value of x minus 5 minus 4 is greater than negative 1. Well, we're still going to isolate that absolute value expression. We cannot combine negative 5 and negative 4. We cannot do that. The x minus 5 is its own expression inside that absolute value symbol. So we cannot combine anything here. So we're going to have to add 4 to both sides. Now that we have the absolute value of x minus 5 all isolated, that's currently greater than 3. So we're going to solve a compound inequality. Since we have a greater symbol, we are going to be using the compound or. And this also sounds very similar. Greater, we're using or whenever we have those absolute value inequalities. We have the absolute value of x minus 5 is greater than 3. We're going to change that into x minus 5 is greater than 3. That looks very similar to the original. And then we're going to flip the inequality sign as well as the value of our number of comparisons. So we'll have x minus 5 is less than negative 3. And now we are going to solve it and graph it. We're going to add 5 to both sides, and this happens at the same time. So now we end up with x is less than 2 or x is greater than 8. And we can't think of a number that's less than 2 and also at the same time bigger than 8, which is why we have the or thrown in there, because we are going to be having two answers that go in opposite directions and opposite mindsets. We can't have a number that's less than 2, but it's also bigger than 8. It doesn't happen, which is why we have the or setting. So then we're going to graph it just like we normally would. We're going to have an open circle at 2, and the shading going to the left because it's the less than numbers, an open circle with 8 going to the right because it's the numbers that are bigger than 8. Awesome, folks. Great job. With this in mind, please work on problems 5 through 8 on the note sheet. And we do have 2 more examples to go through that are not on your guided notes. So you will have to take some notes. So please work on problems 5 through 8 on the note sheet and then resume when you are ready to move on. All right, if you listen to my voice, that means that you have worked on problems 5 through 8 on the note sheet and you are ready to take some notes. So just like equations, we have absolute value inequality special cases. So let's go through the first special case. Let's say we want to solve this inequality. We have an absolute value inequality of x plus 2 minus 5 is less than negative 10. First thing we want to do, as always, is we want to isolate that absolute value. So we're going to add 5 to both sides, and we get the absolute value of x plus 2 is less than negative 5. And we ask ourselves, can we simplify any more? No, we cannot. So let's look at what our current inequality says. We have the absolute value of x plus 2 is less than negative 5. But what do we know about absolute values? They're always going to be what kind of number? Yeah, they're always going to be a positive number. So is it possible to have a positive number be less than a negative number? No, this is false. So we're going to have a no solution, since an absolute value can't be less than a negative number. It always is positive, and it's not possible to have a positive number coming from our absolute value. It doesn't matter what the number currently inside the absolute value is, the result of the absolute value being less than a negative. The result of an absolute value is always going to be positive. So since we have a result of a positive less than a negative, that doesn't make any sense. It can't exist, which is why we get the no solution. So we have to do one further step here, because we do need to look at our final answer and compare, saying, hey, does this make sense so far? And I see a lot of students falter with our second special case. So without further ado, let's go on to a second special case. Well, let's say we have the absolute value of 2y plus 4 is greater than 2. A lot of students make assumptions, and you have to solve before a statement is going to be made. So let's solve this. We have the absolute value of 2y plus 4 is greater than 2. We want to isolate the absolute value symbol, so we're going to have to subtract 4 on both sides. And now we have the absolute value of 2y is greater than negative 2. So really what this is saying is that a positive outcome, which is always a positive outcome for our absolute value, is greater than a negative number. Well, it doesn't matter what value of y we plug in. We will always have a positive number being bigger or greater than a negative number. This is always going to be true. So we're going to say our answer is many solutions. You sometimes will hear it being referred to as all real numbers. You sometimes will hear it as infinitely many solutions. All of them are the same. Typically within algebra, we do want to use all real numbers, but if you're saying infinitely many solutions or many solutions, I understand what you are trying to say. And again, this is always going to be true because we have a positive number being greater than a negative. So since that will always happen, we end up with all real numbers because an absolute value has to be positive. Folks, great job today. Jot down any questions that you have and come to class with them as we will be going over it. I'm really proud of you so far. You are working really hard. So keep up the great work, folks, and let me know if you have any questions. Have a good one.